In this lecture, we will discuss a useful model that describes the four brain processing systems involved in reading. The four-part processing model is discussed in the text for this course, Seidenberg Chapter 7 and Motes Chapter 1. It was originally proposed by Seidenberg and McClellan in 1989 as a synthesis of their experiments on the nature of skilled and unskilled reading. This is described in Seidenberg's Chapter 7 as the general triangle framework for models of reading, where words are represented by orthographic, spelling, phonological, sounds, and semantic, meaning, codes. As Seidenberg notes, reading involves using orthography to compute the semantic and phonological codes for words, which can then be used in performing various tasks, comprehending words, pronouncing them aloud, and deciding if a letter string is a legal Scrabble word. The model was discussed and slightly adapted in length in Marilyn Adams' 1990 seminal book, Beginning to Read, Thinking and Learning About Print, and also in Rayner et al.'s articles published in 2001 and 2002. It represents the systems depicted in Dewan's work describing the circuitry of the reading brain discussed in the last lectures and video. It is a helpful simplification of skilled reading and was offered as an alternative to the highly flawed three-cueing system model proposed by the whole language advocates to guide instructional decisions. The three-cueing system model proposed that word recognition depended on three systems of linguistic cues that reside in the text. 1. Graphophonemic, visual system. 2. Semantic system. And 3. Syntactic system. The cueing system has been embedded in miscue analysis procedures used in running record assessments and also used as a rationale for the whole language and balanced literacy approaches to instruction. This reading instruction de-emphasizes phonological awareness in phonics and overemphasizes the role of meaning in reading words. The four-part processing model is helpful to understand the ways reading problems can occur and what reading instruction should focus on. As Motes and Tolman 2009 note, the model reminds us that instruction should aim to educate all of the processing systems and enable them to work together. All components of instruction are important: phonological, orthographic, phonics, spelling and fluency, meaning and context, vocabulary and background knowledge. Let's talk about each processor in turn in terms of its role and how it contributes to effective reading and writing instruction. The phonological processor enables us to perceive, remember, interpret, manipulate, and produce the speech sounds in English, or whatever language we are learning to read in. This includes imitating the prosody of language, that intonation of our speech patterns, stress certain syllables as we pronounce the words, distinguish words that sound similar, remember a string of words, retrieve words that we know, hold speech sounds in our memory so that we can manipulate them and write them down. The phonological processor has a number of jobs connected to perception of speech, memory for speech sounds, and speech production articulation. Children who have trouble with processing phonological information often have difficulty with learning to read. It is a hallmark of dyslexia. Children have difficulty with learning and remembering letter sounds, blending sounds, spelling, and difficulty recognizing the subtle differences between similar words. This is represented in the simple view of reading in the word recognition domain, along with the orthographic processor. This involves print. The orthographic processing system is involved in receiving the visual information from the printed page. It recognizes letters, punctuation marks, spaces, and the letter patterns in words. It enables us to copy lines of print, recognize words as whole units, or remember letter sequences for spelling. If the letters or letter sequences are familiar, we associate them with sounds and meaning, the influence of the phonological processor and the meaning processor. It stores information about print that is necessary for word recognition and spelling. Children with orthographic processing concerns are prevalent in the population of children who struggle to learn to read and spell. The meaning or semantic processor is the brain network that processes meaning. Many regions of the brain are involved in understanding a word once it is recognized, notably the angular gyrus. The meaning processor interprets the meaning of words in and out of context. Here, our mental dictionaries, our lexicons, store both meanings of words and their pronunciation, influenced by the phonological processor. Our mental dictionary is ideally made up of deep understandings of words and language, as well as rich connections across words and ideas. Children with weak meaning processors will have limited vocabularies for their age and/or weak verbal reasoning skills and have trouble with reading comprehension. The context processor's primary job is to interact with the meaning processor. Thus, it is above the meaning processor. It provides support for the meaning processing system. Context can refer to the words used in a sentence, as well as the overall concepts or events being discussed. Think background knowledge. Well-developed background knowledge and verbal reasoning skills are important to correctly interpret the context and applied meaning. Language comprehension domain of the simple view of reading in the reading rope. The four-part processor is another helpful model to aid in our application of the science of reading to instruction. It explains the cognitive processes that are occurring in the brain as a child reads. It complements and strengthens support for the simple view of reading and the reading rope model.